Alrighty, the final installment here of this some Chapter 4 review. We're going to deal with the big one here, the proofs, the one that seems all big, bad, and scary, okay? So really, what makes proofs most difficult for geometry, the hardest thing in geometry, I should say, is that you really got to know what you're doing in geometry before you can prove something, okay? Because you got to know things like vertical angles, alternate interior angles, what bisector means, what midpoint means, what the reflexive property means. You got to really know those concepts because you're including them all in one proof, okay? Or in this case, we got a couple of proofs that we're dealing with. Okay, so you really got to know your geometry stuff before you can even tackle some of these proofs. Okay, so that's why it's usually the hardest topic in geometry, just because you got to know everything well to actually formulate a proof. Okay. So for the CB classes, college bound, y'all are of course going to have like normal. You're going to have a word bank. For this test, I did like the chapter 3 proofs where you've got a word bank per question. So it's kind of individualized. It's a lot like what you'll have in the spring. Pre-AP class, obviously you're going to have kind of like what you had on chapter 3 tests. So you're going to have a couple more blanks in there. Maybe one that's a little bit easier to do, but it's completely blank, similar to what you have here. But you won't have any word banks, okay? So for the pre-AP folks, you really got to remember all these properties and reasons for your proofs, okay? So for your proofs, we did a little note sheet on proofs, and I'm actually going to pull that up here. I should have pulled it up earlier. Apologize for that. Let's see. Okay. Oops. So you should have these notes 4.4. It was on that CPCTC. Wonderful, magical stuff. So this is our outline on how to do proofs. I actually took it from another teacher. I thought it was great that she had it. Kind of edited it to make it a little bit better for our class, I feel. So it's a really good outline when you're looking at proofs, okay? So, first few steps, okay? So, you've got to mark things that are given to you congruent. Actually mark them on the diagram, okay? So, if I tell you that angle A is congruent to angle D, on those diagrams, actually write out A is congruent to D. If I give it to you, you got to mark it, okay? It's not necessarily going to be drawn in there already for you. Same thing if I give you a set of sides that are congruent, mark those bad boys up, okay? So add that to your diagrams. Then here's where we get to something a little bit different, okay? So again, I talked about this in class. If you've got a midpoint, okay, that means that you've got that point that's in the middle. So I'm going to have two segments that are congruent, okay? So I'm taking one long segment CD, and I'm cutting it into two pieces. And A is in the middle. So I've got from C to A, or AC, and from D to A, or AD. So you would have to have midpoint theorem somewhere in your proof, okay? If I mention that you have an isosceles triangle, you got to have a definition of isosceles somewhere in your proof. So I'm talking about two sides being congruent. If I mention that there's a bisector, now it doesn't just have to be an angle bisector like you have in this case. We could be bisecting a segment. There's nothing against the rules in that, okay? So if I was bisecting a segment, obviously I would have two segments instead of two angles congruent here, okay? And you would have to have definition of bisector for your reason. Now on that proofs quiz that y'all just recently took, there was some people where I had something like A is the midpoint, and then in your proof, you said definition of bisector. Well, no. I mentioned midpoint, so you need to mention midpoint in your proof. Same thing for some of y'all on your quiz. It said in the given something is a bisector, and then you gave me the reason midpoint theorem. No, those aren't interchangeable, okay? If I mention midpoint in the given, you gotta mention midpoint in the proof. If I mention bisector in the given, you gotta mention just bisector in the proof. Okay, so hopefully that clarifies some things. When you look at the next part, okay, vertical angles. So these are things that we're adding visually, okay, to our proofs. So you've got vertical angles. It's a vertical angle theorem. Didn't see a big issue of that on the quiz. Reflexive, that's your shared side. Again, didn't see a big issue with that on the quiz. Just a helpful reminder there. Okay. Remember also alternate interior angles. Okay, that's when I've got some sides that are parallel. If I go to look at step 2, so now I have marked my diagram up. I've marked the bisectors, I've marked the midpoints, I've marked vertical angles, shared sides. Feel like I'm missing something. Alternate interior angles, that's what it was. I have marked that thing to pieces, okay? So once I've got that, then I can actually do what we did for the triangle congruencies. That was that pink video. So that was that 4th video, I think it was, that I did. We got a name. How are the triangles congruent? By side, 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 side angle, side, whatever. Okay. So for some of your proofs, if I pull up your chapter review here, you're going to end at the triangles being congruent by side, 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 side angle, side, whatever. Okay. For some of them, like for 16 and 17, you're going one step beyond. Okay. So it's like Buzz Lightyear's favorite, to infinity and beyond. So he would be going one step beyond the triangles, okay? So when you're going one step beyond the triangles, okay? So here's one step beyond the triangles. You're going to have two pieces, so either sides or angles, okay? That you didn't mark earlier, okay? If I'm trying to show that two sides or two angles that we didn't mark earlier are congruent, it's that CPCTC, so corresponding parts. Talked about that in the first video. Okay, looking at number 1 more specifically on your test review. So corresponding parts, those are the parts that match between the two triangles of congruent triangles. That's what's special about them that we proved earlier. Step 2 there. Those corresponding parts, we're saying they are congruent. So if you look at the example here, C and A, they're corresponding parts, and they're going to be congruent. So if that last reason is going to be CPCTC. Same thing for 17. BC and BD, now I can't use those to prove the triangles are congruent, but once I've got those triangles, I can use CPCTC for the last step to say BC is the same thing as BD. Okay? So when you're looking at these, remember, find the things on your diagram that can be marked congruent, like vertical angles, shared sides, alternate interior angles. See if I've written anything else in the given that's important to you, like bisector, isosceles triangle, midpoint. Okay? Once you've got that bad boy marked up, then you can go ahead and say that the triangles are congruent. Okay? The key with the proofs, anything you mark on the diagram, you gotta list in your proof, and vice versa. So if I give you a proof that's partially filled in, and it has like two angles congruent as part of that proof, you better have those things marked on your diagram. Okay, that threw a couple of y'all off on the first question on your quiz, just because there's a couple different ways you could do that one. Some of y'all tried to use like vertical angles for that first one, but I didn't have vertical angles included. I had midpoint theorem included. Okay, so just be careful with that. Anything that's in the proof needs to be marked on the diagram, and vice versa. Anything that you mark on the diagram, you better include it in your proof. Okay, so your proof and your diagram should match. Okay, so we'll do an example of one that's a little bit harder here, and then I'll finish up this video because it's kind of getting a little bit longer. Okay, so let's say that I give you trying to think one that's a little bit harder here. Maybe something like that. So we got A, B, C, D, E, and you are given that AB is parallel to DE, and also that C is the midpoint of BD. We've got to prove that we're going to say AB, instead of just being parallel, we're going to also prove that they are congruent to each other. Whoa, Nelly. Better hold on for this one. Alright, so the first step. This one actually has a couple different ways that you can prove it. Okay, and I'm going to actually show two different ways that you can prove this, just so you can kind of see that, hey, there's more than one right answer here in geometry. Okay, so remember, you got your statements, blah blah blah, reasons. So you know to start with the given. I don't need to discuss that any further, and you'll write that out all beautiful like. Okay, so the next thing that I notice here, I've got parallel lines. As soon as I see parallel lines, it needs to click in my head, alternate interior angles. Okay, so I got B and D. So I'm going to actually say that, you know what? Angle B is congruent to angle D. And I could have picked another pair. Angle A is congruent to angle E. My reason, those are alternate interior angles. Woohoo! Alright, next thing that was given to me, C is the midpoint. Because of that, I know I've got to use midpoint theorem. Notice I'm not using bisector. That's like my pet peeve. Okay, so midpoint, midpoint. They match up. C is the midpoint of what segment? BD. Okay, so when I go to look at BD here, C is in the middle of it. Halfway, the other half. So I've got BC congruent to DC or CD. Either way works. Midpoint theorem. Boom. Alright. Now, I can add vertical angles here, okay? But if I add vertical angles, I gotta include it in my proof. And when I go to do the other example of this proof, I'm gonna include that, okay? So, I'm gonna leave the vertical angles alone for now. Do I have any shared sides? Nope. Not gonna include anything else with that. Already dealt with the parallel lines and the alternate interior angles, okay? So, now I've got to prove that these two triangles are congruent. So I've got triangle ABC is congruent to triangle. So A has a double mark, that's going to match with E. B has a single mark, that's going to match with D. And then C obviously matches together. I've got angle, angle, side is not in between. So if I'm trying to get to the last step, going one beyond the triangles being congruent to what I'm trying to prove, corresponding parts of congruent triangles are congruent. You notice I did not mark AB and DE congruent on this diagram. Okay. Another way that you could have done this one, so let's say instead, got my statements, blah, 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 reasons, we got the given, okay, so I'm going to still include angle B congruent to angle D, alternate interior angles. That was a good one to have, okay? I'm going to also include the vertical angles that I just ignored for the last one. So when I go to name vertical angles, I can't just use like a single letter like I did at B and D. There was only one angle at B and D, okay? At C though, I've got 4 angles. So I've got to use the whole name, okay? It's kind of like if I got 2 Johns in one class. I can't just call John out. I got to use his full name, okay? So for this first one, I've got angle ACB. So since it's at C, C's got to be the center letter. Congruent. I could also add BCA there, by the way. Congruent to DCE, or you could have had angle ECD. Now, I was also given in my proof here that I've got a midpoint, so I still got to use midpoint theorem. You notice that stays the same here, okay? Forgot to put or because you got 2 different proofs here. So I've still got BC congruent to DC. Now when I go to look, these triangles, ABC and EDC, are going to be congruent by angle, side in between angle, angle, side in between angle. And then finally, last step, CP, CTC. So AB congruent to DE. Okay, so again, look at what they give you. Okay, do you use alternate interior angles? Do you maybe use vertical angles as well? You didn't have to use vertical angles. Okay, so you could have saved a line there. So these proofs, there's more than one way to do them. Okay, so there's not one set way that is correct. Okay, or that's the only correct way, I should say. So both of these are correct proofs. You can pick either way, okay? So when you go to look at your ones in the review, basically I'm going to give the shortest way to prove those triangles congruent when you go to look at my answers for the test review, okay? So it's not to mean that what you put is incorrect. It's just maybe I found a way that was a little bit shorter, a little bit more efficient, okay? So if you got questions on those after listening to this video, by all means, please don't hesitate to ask and let me know. Now I finally got it to stop.